Hello. Today we are going to write two contests, and first of them is AtCoder. Can I participate in it? It starts in 5 seconds. In 5 seconds. Great. So what? What's happening? It's not that contest. Here it is. So x is a positive integer less than 10 to the nth, and x is divisible by m. It's an interesting problem. Okay, let's go only n and m. So we will go. What do we need? Maximum positive integer. Maximum positive integer. Okay. So we will try all digits from 1 to 10. What do we do here? First of all, we say that we only need this part of number m, and if is even or divisible by 5, then this is not okay. After that, we say that we will try all numbers from 1 to n digits. Yeah. So I say that Rs is product of Rs and 10 modular m, not m capital but small m, and even this m. And if Rs equals 1, then answer is maximum of answer and pair of j and I. So if answer dot x cout and else cout -1, I guess. So 6/8 should be here. Seven eighths. Why 7/8? Ah, what? What? I don't understand. Why 7? It is always divisible. I don't understand. What's happening? Why? Why? Ah, I get it. So it should be like this. Yeah, it should be like this. Okay, now it's right. Yeah. Okay. I don't want it like this. I just want LLRS times 10LL percent MM. So now it should be 9/8. Okay. This should be 9. This should be -1. This should be 39s or something like this. Why 38s? It should be 39s. RS is 0? Why? Ah, uh, great. Okay, I think I can submit it. We're slow again though. Accept it. But we are bad. 640 plays. Oh no. I think we can just sort both sequences and try both answers. It should be it should be the best. Sorry. Not the best moment, but I had some food. So let's try my pseudo solution. So first of all, we do this. And then we have to find the maximum increasing the sequence in C. Okay. Yeah, they should be fine. I guess just like, okay, let it be like this. No, incorrect. Why? So it's 8, and also this should be 10. Extraordinary. constructive problem. So we'll try to make as many even numbers as possible. And in principle, this is not hard. Yeah. So for example, we make these numbers even, this number's odd, and the only problem is these numbers which can be prime. Yeah, so we just have to find any n pairs of numbers that don't add to a prime number. So how, and also if we have an odd number, then this might be harder because the number of even and odd numbers is not equal. So how would we solve it? How would we solve it? I guess we can try to make many numbers in the odd case. We may try and make a lot of n squared sums. Yeah, for example, we try 1 and n squared minus 1, 3 and n squared minus 3, etc. And we can also do it here, but here's the problem. We need to make such pairs that this number is also composite. It should be also a composite number. So how would we do it? It's kind of easy. So we need to find two even numbers. We just need to find two even numbers such that, uh, or two odd numbers such that the sum is composite. What is the sum? The sum is a minus b plus n squared. So n squared plus 2 or plus 4 or plus 6, something like this. Fine. First of all, let's solve this problem for odd numbers or for even number. So for even numbers, we just fill the left part with, for example, upper part with odd numbers and the lower part with even numbers. And start with odd number 1. So we say that we say that a I no, not like this. We say that aij equals current number, where current number is incremented by 2 every time. Then we say that c equals n times n minus 1 minus. It's interesting because we cannot just take n squared minus 1. What's the point? We need some odd number near n squared. N squared minus 1 is actually always composite. So we say that c equals n times n minus 2. Yeah. We say that aij equals c. Yeah. And that will work, but if c is less than 1, then c equals n times n. Great. Let's try it for 4. I should also output the answer, please. Yeah, that's great. That's great. And the only case is the odd case. So basically we do the same thing, but we have this strange change. So it should be like this. So this is odd, this is even. And here we have n squared and squared and squared and squared and squared, and this number should be not n squared, but it also has to be odd. Yeah. So what it can be? It can be n squared plus 2, n squared minus 2, but these both can be prime numbers. For example, in case of 9, 7, and 11 are odd, are composite number, prime numbers. I guess And squared plus 6 or plus 4 should be okay. Yeah, for example, in case of 9, can we do it in case of 9? Let's check it. So we need put odd numbers here and even numbers here. What can we do? So 9 is okay, but we cannot have 9. 7 is okay, 11, 7 is not okay, 11 is not okay, 5 is not okay, and 13 is not okay. So 9 is not a good number because it has two pairs of twin primes near it. So maybe 15. Okay, so 9, and here we have, no, I mean, we have 6 here. So this should be like, we cannot use 9, we can use 8. So it becomes 9 is here, 1, 8, no, 8 is not here, 1, 8, here we have 7, here we have 2, 4, 5, 3, 6. Okay. Maybe I just make a number which is divisible by 3. That's it. Can I do it? Can I just make a number which is divisible by 3? Can I just make a number which is divisible by 3? So I can. Yes, I can. But it's not easy. I don't know. Let's kind of plan it. So we have this type of width 3, and we do this staircase, which is stair. So I have to put here and here two numbers which are. So let's just fill this stripe somehow. I think we will just fill this stripe somehow. So I start with 1, 3. Okay, here we will have some issue. Because I can't just have 1, 3 here, can I? 1, 3. Here I have 8, 6. And 6 is the only number that can be put here. And this will be a problem. This will be a problem. Because I can't put here 0. Yeah, that's unfortunate. Okay, maybe 3 is just a special case. Ten through 1, 5, 7, 8. Five, 7, 8, 4, 2, 6. Else, what do I do here? In this case, again, I just go with some regular numbers, 1, 3, 5, and here will be 24, 22, 20. Now I have to put here any number which is, can I just put here 7, for example? No, I cannot. So I need some number such that 5 plus n minus x n squared minus x is divisible by 3. There is something and there is it. So I have to skip at most 2 numbers. Okay, this is of course possible. So first of all, I fill the central part. So here I say that a n halved j is c and c plus equals 2. Int d equals c plus 2, and while d minus c plus n squared is equal to 0, I have to put them in skipped and d plus equals 2. Okay, after that, I put them in the next row. And I say that a n halved minus 1 j equals c. Also here I say that a n halved plus 1 j equals n squared minus c. And also I do it here. Excellent. And now I just have to fill all the numbers. Somehow. Absolutely somehow. And I do it. So I do it. There's some problem with asymmetry. Yeah, there is some problem with asymmetry. Okay, what have I filled so far? I have filled these numbers. So I put 9 here, for example. Let's put 9 here. What is it? It's a n halved minus 1 n halved, I guess. God. Okay. So if I equals n halved minus 1 and j equal is at least n halved, then break. Else, if if n skipped is less than skipped dot size, then I say that a ij equals skipped n skipped a n minus 1 minus I n minus j minus y I 1 equals n times n minus skipped and skipped and n plus plus and skipped. Okay, we'll do like this. So here I say plus plus and skipped and put num equals skipped and skipped. And else I say that put num equals c and c plus equals 2. Then I say that it is put num and it is n squared minus put num. So let's check it. So here this is okay, as I said, it's just 9, 9, 15, 9. Let's try 4. This is fully okay. For 5, we have something strange. 25, 25, 25, 14. No, something bad happened. This is incorrect. This is incorrect. Ah. Yeah. So come again. 25, 25, 25. Ah, this is awful. Why is it 25 here? Well, how did this happen? Okay, it should be 25 here. But this number has... Ah, this number is 21. This is okay. 25, 25. But now I have skipped 7 and 9. And they should be in skipped numbers. Are they there? Nothing is skipped. 7 is skipped. 7 is skipped. Why is skipped empty? Skipped shouldn't be empty. Ah, okay. Aha. Okay, let's try 6. Let's try 7. 49, 49, 49, 49, 45, 49, etc. Let's try 9 and send afterwards. 81, 81, 81, 81, 81. 79 is not correct. So this is bad. This is 79, which is a prime number. This should be, sorry, C minus 2, of course. So now is 75. This is okay. This all is okay. Let's try 7. 47 now is not correct. What? Maybe here I have to have plus and here I have to have minus. So now it's 45. Yeah. For 5 it will be 21, and for 9 75. Yeah, this took a while, but after all we have succeeded. Great. I think our place is now worse than that it was before the before. Yeah, we are better, but we are very slow. Let's look at the problem D. There are n pieces placed in its coordinates on a number line. Nobody solved D so far. Hina 239 solved D. I don't know. I don't know. Okay, let's sort the points and go from left to right. Yes, so we know the whole root of some point, and now we moved it a bit to the right. Yeah. So every time when their signs are equal, this is just the same. Yeah. When their signs are the same, they just go the same. But what happens if they, for example, go somewhere like here and they get different signs? After that, this goes here and this goes here, and they kind of swap. So after that, they have different destinies. After that, they have different destinies. So what? Hmm. So let's take, for example, the median point and see its root. It did something, it did something, it did something. It's not easy. Maybe this is some sort of segment tree. Maybe this is some sort of segment tree. Hmm. Possibly this is some sort of segment tree. So for each point, we know that. Maybe we just take the median, then take some other median. Yeah, and mostly we do it in linear time, but sometimes it's not a linear. I don't know. I think it's possible that all points are mixed up in logarithmic time, and actually we are doing everything in logarithmic in linear time. Yeah, I think all points can mix up. in like logarithmic time. Maybe we can go from the top, from the end to the beginning. So in the end, we yeah, in the end we just jump plus dm here and plus dm here and minus dm here. Okay, this is kind of understandable. What happened the step before that? Before that, we had dm minus 1 here and dm minus 1 here. Mhm. So in total with dm, what do we have? Oh, sorry. We have something like this. Points which are okay. First of all, points dm minus 1 and dm minus 1, they remain unchanged. These points go plus dm minus 1 plus dm. These points go minus plus dm minus 1 minus dm. This is vice versa. So this is minus dm plus minus 1 plus dm. And these points, they are minus dm minus 1 and minus dm. First of all, I think we can all agree that this is some sort of mm, so this is some sort of symmetric position. So we can only look at positive numbers and we can assume that they always go to the left. But if it goes into the border, then it jumps to the right and we increment increment the number of collisions with the left border. So actually what happens is we have something. Yeah, we have something. We have several points. And we have border D. And essentially these points from 0 to D, they they can do reverse. They can do reverse. And these points get minus D. That's it. So the points on the left they get reversed, and the points on the right they're decremented by D. Maybe we can again do it in the reverse order. So we want to know which points land in the 0 in the end, and which points land somewhere. So we are undoing DM. How can we undo DM? How can we undo DM? So essentially, the points end up here if they were here or here. Hmm. The points end up here if they were here or here, etc. And the points end up here if they were to the right. I don't know how to solve this. Maybe the problems E or F are not that impossible. Let R be a rational number and be a cube with the numerator and denominator of R. Let the base R expansion be this sequence. AI is an integer between 0 and p minus 1. Hmm. AI is an integer between 0 and p minus 1. So we can subtract the maximum number that can be put inside. Okay. I can't understand. What? So how do I do it? Okay, for example, I want let's see, 3 and 3 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what do we have here? So for 3, I just know 1, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, 1, 0, 0. For 3/3, we have something else. We have 1, 2, 2, 0, 2, 1, 2, 2, 2, 1, 0, 2, 1, 1, 2, 1, 2, 2, 1, 0, 0. Okay, first of all, it's easier to see the last number. I mean, the last digit. It's just the residue modulo 3 because we have to take it. Or else the left part will not be divisible by p, and this is very bad. Ah, yes, so I got it. We take the residue, we subtract it. After that, we multiply the number by p, q over p, and we repeat. Yes, maybe I understand now. Oh, Omnic solved f. So this is indeed possible. How would we do it? Is it always 2? Is this digit always 2? It's kind of strange. let's make some experiments. It's time for experiments. Oh yeah, in the end, it is always at least 2. So the first digit is always kind of divisible by q. Yeah, in the end, the last digit is always divisible by q. Hmm. Okay, I guess we will do. I guess so. We track our. We have to track something. I will think now. But first, I reverse whole B. Okay. Great. So also we see that this digit is always 1 and something else. Okay, what do we do? I think so. We have L and R, and we need to output all numbers here. Yeah. So how can we do it? First of all, we find L. First of all, we find L. How do we do it? So we have some string of digits. We say, what if I add a 0 here? Yeah, now, so this is, if we don't add any digits, so it's epsilon, then this is the whole list of the numbers. And then we say, let me try 1 here in the beginning. Yeah. This means that we need to find a number of numbers which have a first digit 1. Okay, assume that we find this number, and this is here, somewhere like here. So then we try number 2, digit 2. This is kind of here. 3 times 10 to the 5th power. This is actually 101. So, okay. Assume we have some string of digits. What does it mean? It means some beginning. It means some beginning. For example, we see a 1 here. Yeah, this means that let's go from the left to right. What does it mean? It means that I have some number, I multiply it by r, and then I add the next digit. Okay. So what happens when I do it? I multiply it by r and add a new digit. Again, multiply by r and add a new digit. So always when I multiply it by r, okay, assume that this is not a whole number. So this is some sort of fraction. What happens then? I multiply by r. This is even more. So assume that this is fraction and it is its denominator is divisible by p from the q. Some some prime number x from q. So x divides q. I multiply it by r and it indeed is divisible by x. Then I add some digit and it's still divisible by x. And in the end, it will be divisible by x, and this is bad. So I actually, it is always a whole number. It is always an integer. So every prefix of this thing is also an integer. That makes sense. That makes sense. So I need some sort of sub procedure. Procedure. Mm, is it monotonic? Oh, what the hell? Is this monotonic? I don't know. It should be monotonic, but I'm not sure. Sometimes it's not monotonic, but it's when. Okay. So it's bad if it's bad if this, and it's bad if this. Okay, nothing is bad. Nothing is bad so far. Okay, I think this is increasing. I think this is increasing. This is indeed increasing. So if this is increasing sequence, then what do I have? So I have a sequence of, okay, 1, etc. n. And I know that these are the numbers that start with epsilon. How can I decrease this range? I say, let's say that, first of all, let's try all digits from 1 to p minus 1. And how many numbers start with 1? How can I check it? I don't know how can I check it. How I can check it. How many numbers start with 1? Maybe some sort of dynamic programming? But P and Q are big numbers. Hmm, I don't know. Okay, well, again, what is the procedure? Oh, I can't even do this because this is madness. I can jump by Q, of course, but still, this is a lot of numbers. Hmm. Ah, I have an idea. I have an idea. So I start with some string. What can I do? I can find this number and then always put something minimum, or minimum number which is possible, and maximum number which is possible. And that with that I can find the segment. With that I can find the segment. So all numbers from L to R. What do I do if I want to find them all? Ah, I cannot, or I can. Okay, first of all, I can just find L and then make the increment n times. Let me do it. Fine. This is not that hard. So what I do is find num uh, pqnl or not. Yeah. Okay, so what? Okay, maybe this is some sort of a lot of binary searches. Let's see. First of all, I want to put 101, 100. Here I have. Okay, and I want to look at a lot of binary searches. So what do we have here? Oh, it's a long sequence. 3297. So can I multiply this number by 3000? Not really. This would be bad. This will be bad. This will be bad. Awful. It's just awful. If we haven't any other choice, so we do it. So first of all, for each length, we want to find this number. So first of all, we need to find the minimum number of each length. Let's try it. Let's try to do it. Let's try and do it. So while true, we say, okay, we need a minimum number of each length. Int length equals mn 0, mn dot size So what do we say? We say that if I equals 0, car_num equals q, else car_num plus equals b minus. What do we want? We want it to be divisible by Q. Something like this. Then we say that car num divides equals Q equals car num times P. We want it and if new car num divides by P is not equal Q, we say that good is false. Else, okay, no, we don't need else. So if not good, then break. But else, a man dot push back car num. Okay, let's see out all these numbers. What? So it's kind of gradually, steadily grows. Okay, we have all these numbers. So what next? What's next? Now I have to find this border via binary search. Okay, now I have for each length, I know what is the number of numbers with this length. So how can I proceed? How can I proceed? It's a strange problem, yeah. And I think I will get time limit exceeded. Because it's really a strange problem. It's a really strange problem. Madness. Just pure madness. So what do I need? I need to eliminate L minus 1 numbers, okay? So now I have some numbers. Okay, now I point at minimum numbers, okay? So what I need is I need to just jump with these pointers. With these pointers. How can I jump with these pointers? It's a tough question. So I have some. I have some beginnings. Okay, maybe I have a binary search. Ah, ah, I have an idea. I have an idea. I have an idea. So I make a binary search on this segment. First of all, I try this end. Okay. Okay, I have to try this end. So I have to try the number n. Okay, I just I write the function of find num of p, q, n, l, and this is the first part of it. So what do I do here? I have number n. Something like this. Also, we have to write the function input. So I have this number, and while nn, what do I say? I say that so I need to find numbers that are at most nn. First of all, I say that int I equals mn.size minus 1. So I say that LOE plus equals mn nn minus mn of dx minus dx, and nn equals nn minus nn percent q, or just nn divided by q times, no, nn minus nn divided by q times divided by p times q. That's it. Great. Okay, and if LOE is first of all, if LOE equals L, then I return N. And after that, I have two options. If LOE is less than L, this means that NN is too small. So now I have to make a binary search from NN yes. So L and R. So if it is small, then L equals so I try this and I know that this is too small. And R equals mn dot back minus 1. And R is at least good. What else? Else I say that L equals mn dot back and R equals N. So while R minus L is at least 2, I do something. I say LL M equals L plus R halved. Then I perform this procedure. So also here I say that addend is I have to add all numbers from mn back to nn. Always. I have to add them all. And here I say that add equals 0. And again, I do this. It's too little time. So here I have basic digs equals mn dot size -2, and here I say that it is -1. Here I say that digs is basic digs, and while nn this and this, and if lower is at least, if lower is equal to L, then I say return M, but basically if lower is less than L, then I say that it's too small number, so L equals L, else R equals M, M. Okay, and in the end, actually return R. And after all, I have to make a procedure to increase a number. Okay, first of all, we need to make 2R. Okay, 2R is created, and now I have to make an increment. So LLN and LLCar const VE array const int p const int q and const LLM. Okay, first of all, what do I say? First of all, I try to increase the length. Try to increase the length. So I say that maybe we try to new car equals car. It is something like here. So if new car num percent I did something wrong. What's happening? I don't understand it. I always have zero. Yeah, I always have zero. That's it. So here, what do I do? First of all, I try to add a zero. Yeah. So if car, first of all, if I want to add zero, then car should be divisible by q. Then I can try it, and I do it. So I say that ll new car equals car. I say new digit. I don't need a new digit. That's it. A new car. Okay, what do I do? What do I do? What do I do? So new car equals car. New car plus equals ras. No, I don't do it. I just divide by q and multiply by p. And if this new number is divisible by p, then I can do it. I say that car equals new, and also I need that new car num is at most n. What's wrong with it? Okay, I say that car is new car num, and I push back a zero. Great. And if this is impossible, then I say while r dot back equals p minus 1, yeah, while it equals p minus 1, and I can increase it. I just say that car equals car minus equals r dot back, car divides equals p, car multiplies equals q, and r dot pop back. And in the end, I say that r dot back plus plus and plus plus car and return it. Okay, so great. I guess that's it. And this should work. This should work. 9, 10, 11? Why 9, 10, 11? Ah, I cannot do it. I cannot do it. So So R is empty. But why did it happen? What is it initially? So it's 9, then 4. It's anyway, it's wrong. Anyway, it's wrong. This should be 1 in the this should be 1 in the beginning. Okay, I again lost. Sad, guys, it's sad. Again 9? Why 9? This is wrong. Why 0? It should be 1. Ah, this is wrong. No, it's again 9. Why 9? Okay, this should be 0. What is L? L should be 1. Okay. What? So it's wrong. It's wrong that I need to take n. Maybe I don't understand something. Maybe I don't understand something. Ah, ah. So it's not even true that I need to take. Ah, oh, I got it. I got it. Guys, I could be here, but I was too slow. And it's not the first time that I'm too slow. It is sad. It's just sad. Omni did it in 1 hour, and I had more than 1 hour. Why didn't I solve it? Ah. So all I need is find the else number. How can I do it? So we have some sort of minimum number on with n digits. Yeah. What do we do if we have it with k digits? Minimum number with k digits. Minimum number with k digits. What do we do with it? So we try it, and if it is too big, then we slide to the previous number. Yeah. So if this is too big, then we just slide to the previous number. How? What's happening? I mean, so we have the minimum number with one digit. Yeah. We have some numbers with two digits. We have some numbers with three digits. We have some numbers with four digits, with five digits. So, and this is number n, the maximum number that we can afford with five digits, for example. First of all, we tried if there are L numbers here. And if not, then we can try this number. If there are L numbers here. And if it's not, then we can try this. And if not, we can try this, and etc. until we are here. So, okay. for basic. And also it could happen that there are less than L numbers here. Yeah. In this case, yeah, we do. Oh no. Okay, just ignore all this shit. I don't want to fix this problem. I failed. That's it. And coders are too hard. Okay, fine. Thank you for watching. You kinda felt the vibe of problem F. And my solution can be upgraded to correct solution if you a bit faster than me. Thank you.